find the cross product of these two vectors. This question is purely algorithmic. I've even set out the formula for it before we even started the video. Usually I hide it like this, but right now I'm very explicit about it because this is really the nature of the question. You take what's it called? A determinant like this one. It's a determinant. And it's a determinant that has vectors inside. So these are unit vectors, just to be clear. And instead of u, I put in the coordinates of u. 3, 2, and minus 1. Instead of v, I put in the coordinates of 1, 1, and 0. Let me check that I copied these numbers correctly. I did. So this means that I don't have to shoot this video once again. Okay, how do you compute a determinant? Well, you pick a row. In our case, we would like to pick this row. If I pick this row, there is a certain, how do I say this? I don't want to say map, but there's a certain thing that you need to remember. Maybe that's how I should say it. It's this thing. I don't know what to call it, but let me show you how it's done. So if I use this row to find the determinant, then I choose I, and I break it down into a smaller determinant. I choose j, and I multiply it by a smaller determinant, and then I use k, and I multiply it by a smaller determinant. Next, I want to assign the values of signs here. Because this I is in this very nice position, I give it a positive. This j is in this, well, I guess it is a nice position. I give it a minus, and this I give it a plus for the same reason. And now I need to figure out what the smaller matrices are. The smaller matrices are always the ones which are not in the rows and diagonals. So you do like this, like that. You look at the row and column in which your entry is at. So I'm at I eliminate these two, and I immediately get my intended smaller determinant. 2 minus 1, 1, 0. I hope you've seen this somewhere before. Anyway, I do the same thing for j. I need to... Yes. So I get 3 minus 1, 1 and 0. I do this one more time. I get 3, 2, 1, 1. Good. And now I just need to work out the smaller determinant, which is evaluated as follows. So this should be some sort of definition for you. You have a determinant which is two-dimensional like this one. It is evaluated as follows. So it is always AD minus BC. This is always how it's done. AD minus BC. So I take this, I do AD minus BC, I get 1. I do AD minus BC, I get 1 again. And then I do AD minus BC, I get 1. So this should be the answer, if I have not done any mistake. So let me check this. It seems that I have not done any mistake, which makes me very happy. You get I minus j plus k. Now, these are coordinate vectors. These are direction vectors. So this is another representation of going one step in the direction of I, going a minus one step in the direction of j, and one step in the direction of k. These are direction vectors, you could say. And when you compose these together, this is of course a more compact way to write them. You just choose the coefficients and it is automatically understood that you are talking about this very specific set of vectors. I'll just put it in a nice box and go to the video.